Friends, in last lecture we derived one formula. What is the magnetic field of this current loop on the axis that is at point P here? For that we have taken one current element, then position vector. So this is the magnetic field given by this formula using Biot-Savart law. If you find the direction, then it is in the plane xy plane, but is perpendicular. Yes, perpendicular R also. So it is in this direction. In other way, you can find the direction like this. You take your right hand, अपना दाहिना हाथ लीजिए और ये फिगर पर रखिए. Z परपेंडिकुलर टू द पेज है, तो थंब ऊपर रखना चाहिए. And then you stress, actually put your hand here at this position. Thumb बाहरी दिशा में and stretch your finger in this direction and draw the normal to your palm that comes here. થાય છે આવું? અંગૂઠો ઉપરની દિશામાં, આંગળા આ દિશામાં, તો થંબ તમારું પરપેન્ડિક્યુલર આમ જશે. તો આને પેરેલલ મીન્સ અહીંયા આગળ. આ રીતે તમે ડાયરેક્શન શોધી શકો. પહેલો વેક્ટરમાં થંબ, બીજા વેક્ટરમાં ફિંગર. તો હથેળીને દોરેલો લંબ એ રિઝલ્ટન્ટનો ડાયરેક્શન આવે. So this has two components. One is the x component, this is y component. Y component is cancelled because of diametrically opposite current elements. So we consider only x component, not the y component. Then using the geometry, we calculated magnetic field on the axis is given by mu 0 I r square upon 2 r square plus x square raised to 3 by 2. If you take the center, then x equal to 0. For infinite, r is negligible. For n turns and thickness is small. So you have total 6 formula that we have discussed yesterday. Now today we discuss Amperes Circuital law. Amperes Circuital law. Amperes Circuital law. So actually it is very similar to the Gauss law in electrostatic. Biot-Savart law is also used to find the magnetic field. Amperes Circuital law also used to find the magnetic field. But here condition is that for symmetric this current distribution. What is that? So suppose you have many current conductors, many. I take little bit different from the text for better understanding. So these are the current carrying conductors. And now we take one loop . This current is I1, I2, I3, I4, I5. This loop is such where magnetic field at each point may be constant or at each point magnetic field is perpendicular or zero. So these are the 3 points you have to keep in mind while drawing this loop. It is called Amperes loop. Number 1, at each point magnetic field is constant. Second, may be perpendicular at each point. And third one is zero. એવી જ લૂપ પસંદ કરવાની છે જ્યાં મેગ્નેટિક ફિલ્ડ કોન્સ્ટન્ટ હોય તો ચાલે, એવા પોઈન્ટે જ્યાં મેગ્નેટિક ફિલ્ડ પરપેન્ડિક્યુલર હોય અને જ્યાં મેગ્નેટિક ફિલ્ડ ઝીરો હોય. અહીંયા માની લી મેગ્નેટિક ફિલ્ડ ઇઝ કોન્સ્ટન્ટ. So what is this law? Integration for this loop B dot dl. For a closed loop, this is indication for the closed loop. Magnetic field. We are doing integration, so I divide into small parts. And we do it. And B is in the direction of dl. Suppose maybe, or direction be constant, no problem. Is equal to what? It is a product of mu 0 and algebraic sum of electric current within the loop. Similar to that, if you remember E dot dA. For closed surface, this is for closed loop, this is for closed surface, is equal to sigma q upon epsilon naught. અહીંયા સિગ્મા ક્યુ એટલે કે સરફેસ દ્વારા ઘેરાયેલું ચાર્જનું algebraic sum. Here algebraic sum of the current within the loop. Divided by epsilon 0, here multiply by mu 0. So it is very similar to the Gauss law. In our case, you have 4 currents, 1, 2, 3 and 4. First, second and fourth are flowing in right side. Third one is flowing in left side. So which is positive and which one negative? So what is to be done? Rotate the screw in the direction we do integration. Rotate the screw in the direction we do integration. So when you rotate the screw in this way, so screw is going this direction, right side. So right is positive and left is negative. So in our case, it is mu 0 I1 plus I2 minus I3 plus I4. This current is contributing for magnetic field, but it is not considered in the right side. I5 magnetic field અહીંયા produce કરે છે, but right side માં એનું contribution નથી. This is the Amperes Circuital law. આને કહેવાય છે Amperes Circuital law. ફરીવાર યાદ કરાવી દઉં, લૂપ કેવી પસંદ કરવાની? જ્યાં મેગ્નેટિક ફિલ્ડ કોન્સ્ટન્ટ એવા પોઈન્ટમાંથી પાસ થાય, or મેગ્નેટિક ફિલ્ડ પરપેન્ડિક્યુલર હોય એવા પોઈન્ટમાંથી પાસ થાય, or મેગ્નેટિક ફિલ્ડ ઝીરો હોય, નાબૂદ થતું હોય એવામાંથી પાસ થતું હોય. બરાબર? હવે જો હું I take one conductor and I take loop. Looking to symmetry, magnetic field is constant, so I can take B for this. If I integrate and this radius is R, so it becomes integration B dot dl, in fact, is equal to mu 0 into sigma. Here current only I, so it is I. So if you integrate this, જેનું સંકલન કરીએ તો એ આવશે 2 pi r is equal to mu 0 I. So we get B equal to mu 0 I upon 2 pi r. That we can do it. તો અહીંયા B તમે જુઓ, B you can see it is inversely proportional to R. So as you go away, magnetic field decreases. And very close to that, it is increasing very rapidly. So your magnetic field is very large. As you go away, it is decreases. Second thing is not at constant distance. Suppose I take this 2 centimeter, all the side 2 centimeter, 2, 2. You get constant magnetic field. And second thing, it is in the direction of the loop. So we can say that magnetic field produced by the straight wire is in circular shape. And because of that only, suppose you take one paper and you pass one conductor which carries current I, and if you sprinkle very fine powder of iron, when you pass the current, this powder arrange like this. This because of the magnetic field lines are in circular shape and it is constant. અહીંયા બધી જગ્યાએ constant હશે, એનાથી અહીંયા વધારે હશે પણ એ બી constant હશે, અહીંયાથી વધારે હશે, constant હશે. તો જે ભૂકો છે ગોઠવાઈ જાય છે, તેનું કારણ છે મેગ્નેટિક ફીલ્ડ લાઇનનો શેપ કેવો છે? સર્ક્યુલર છે. Biot-Savart law connects the current and magnetic field. You know, in that formula, left side you have magnetic field, right side you have current. Same thing in this Amperes circuit also. Right side you have current, left side you have magnetic field. Both laws are used to find the magnetic field. Note down one point that this is constant current. તો આ બધું બરાબર છે. સમય સાથે કરંટ બદલાતો નથી. કરંટ remains constant. તો મેગ્નેટિક ફીલ્ડ તમને જે મળે છે એ મળવાનું છે. In Gauss law, charge distribution is fixed, charge is not moving, and અહીંયા current is constant. So using Amperes Circuital law, we can find magnetic field for symmetric current distribution. We take one example. It is already given in the text. That is Udaharan 4.8, illustration 4.8. I go for that. In this figure, this is very long. Circular cross section radius is A. This radius is A. Actually, I draw in different way. This is the conductor. Sorry. This is the conductor. It is long. And radius is A. From here to here it is A. Can you imagine? Current uniformly distributed across the cross section. Calculate the magnetic field in the region where R is less than A. It means inside, from here to anywhere. And in second case, it is R is greater than A. So outside. So what we do, we use Amperes Circuital law. First, we discuss first case, R is less than A. So case 1. Consider Amperes loop of radius R is less than A. And second thing, center of the loop is at the center of the conductor. I can draw like this also. So this is your loop. Okay. Using Amperes Circuital law, what we can write? Integration B dot dl is equal to mu 0 into sigma I, and for a given loop. Now looking to symmetry, B is constant. You can take here or there. B is constant somewhere here, all point. So we can take it outside. Second thing, B is in the direction of dl. So this all are current elements. So B is constant, so it is outside. B dl cos theta. Theta is 0 degree for H point. So cos 0 is 1. Is equal to mu 0. Now current within this, that you calculate. Means current, અહીંયા કેટલો હશે આપણે શોધવાનું છે. How much current is flowing? How we can find? અહીંયા કરંટ મારે શોધવો છે, કેમ શોધાય? ટોટલ કરંટ ઇઝ I. આખા કંડક્ટરનો કરંટ કેટલો છે? તો અહીંયા કેટલો છે મારે શોધવાનો છે. વિચારો. વિચાર્યું? આખું આવું થઈ. અહીંયા કરંટ કેટલો હશે? અહીં આખામાં કેટલો છે? I છે. તો આટલામાં કેટલો હોય? કાંઈ વાંધો નહીં. એક વોટરનો ફ્લો આવે છે ધારો કે, અને વચ્ચે એટલાની પાઇપલાઇન મૂકી દઉં તો ઓછું આવશે કે વધારે? એક વોટર આવે છે બધું, ઓટલો ભાગામાં જોડી દઉં તો અહીંયા પાણી ઓછું થઈ જશે ને? કેટલું થઈ જશે? તો આના એરિયા ઉપર ડિપેન્ડ કરે. તો હું શું કરી શકું? જો આટલો એરિયા હોય તો ટોટલ પાણી વોટર, તો અહીંયા કેટલું? તો સેમ થિંગ ઇઝ હિયર. સમજમાં આવ્યું? So what is the current? So if pi r square area, pi a square area, then current is I. So total area is pi a square. So this total area is pi a square. Then pi r square how much? So it is I prime is equal to r square upon a square into I. समझ में आयु ने? तो I write r square upon a square into I. Okay. Now, if you do integration for this loop, આ લૂપ માટે હું ઇન્ટિગ્રેશન કરું તો how much? So it is circumference 2 pi r is equal to mu 0 r square upon a square I. And so what is the magnetic field B? 1 r is cancelled out. So what we get? B is equal to mu 0 upon 2 pi a square I into r. Now you see here, mu 0 constant, I is constant, 2 pi is constant, a square is constant. So we can say that B is proportional to R. B is proportional to R, where R is less than A. So from here to here it is increases. અહીંયા સુધી increase થશે એટલી આપણે ખબર પડી. Now I take loop outside. So this is the loop, or I can take loop here. This is the loop. Okay. Again I use Amperes Circuital law. Here R is greater than A. So integration B dot dl is equal to mu 0 sigma I. B is constant, similar to that previous case. dl cos 0 is 1. So mu 0. Now you look at here. Within this loop, kitla current है? What is the current? How much? So total current. यहाँ पर कम था कि total current I, तो here current less. यहाँ पर कितनी भी बड़ी लूप लो, लेकिन करंट तो वही रहने वाला है I. ठीक है? So it remains I. Now integration is over the Amperes loop. So integration तो यहाँ, this is my radius now R. R is greater than A. So what is the integration of this? 2 pi R is equal to mu 0 I. And therefore B is equal to mu 0 I upon 2 pi 1 upon R. So here shows that B is inversely proportional to R. Proportional to R, and here inversely proportional to R. So if I take this conductor, okay, I try to draw with the graph. This is the center. How B is increases with R. How B is increases with R. That I want to plot it. This is R. Linearly increase you, it become maximum, and then it decrease 1 upon R. So it is graph looks like this. B is a function of R. As you go away, it is decreases. At infinity becomes 0. At the center it is 0. Where you get the magnetic field maximum? At the surface. At the surface. So B at the surface. I can use first formula or second formula. You will get same answer. If I use first equation, then mu 0 I upon 2 pi A square into R. So R is equal to A. One A is cancelled out. So what you get? Mu 0 I upon 2 pi A. And if you use this equation, then I use mu 0 I upon 2 pi 1 upon R is 1 upon A. So whether you use first equation or second, magnetic field calculated on the surface is same. Mu 0 I upon 2 pi A, mu 0 I upon 2 pi A. So this is true when R is greater than or equal to A, and this is true when R is less than or equal to A. Okay. So this is for very long conductor. And if it is a short conductor, then we don't have derivation, but we memorize it. Suppose conductor is smaller one, and I am finding what is the magnetic field here. Current is I. So for that, the distance, suppose I say y, this angle I say suppose alpha, and this angle I say beta. So formula, you remember, B is equal to mu 0 I upon 4 pi y sine alpha plus sine beta. Magnetic field at point P. How far? At distance y. For short conductor. For short conductor. યાદ રાખો આલ્ફા નોર્મલ સાથે બનાવેલ એંગલ છે, એન્ડ સાથે નહીં. જો એન્ડ સાથે હોય તો મારે અહીંયા લેવાનું cos alpha plus cos beta. If this is alpha and this is beta, then I have to take cos alpha and cos beta. Suppose this is away, become infinite. આનું ઇન્ફાઇનાઇટ લઈ જાઓ તો આલ્ફા કેટલું થાય વિચારો. અહીંયા એન્ડ હોય તો મારે આ લાઈન દોરવાની છે, અહીંયા હોય તો અહીંયા દોરવાની, એમ કરતા ઇન્ફાઇનાઇટ કેટલા થશે આલ્ફા વિચાર્યો? 90. અને આ બી ઇન્ફાઇનાઇટ હોય તો એ બી 90. તો if it is infinite, then it become long. So alpha is equal to 90, beta is equal to 90. And if you put it for infinite long, beta is equal to mu 0 I upon 4 pi y into 2. So you will get mu 0 I upon 2 pi y. So again, we get same formula here, what we get it. This is for outside, long one. So we can derive that formula from this formula. So this is for long one. Suppose point is somewhere here and one side it is infinite. હવે P લગે તમારે યાદ રહે એટલા માટે. હવે અહીંયા જોતું હોય તો one side is infinite, so alpha is 90 but beta is equal to 0. So magnetic field at point P1 તો મારી પાસે શું થઈ જશે? mu 0 I upon 4 pi y sine 90 plus sine 0. Angle here is 0. So this becomes mu 0 I upon 4 pi y. Okay. And જો point અહીંયાથી બી દૂર હોય, we'll discuss later on. Okay. Sometimes dimensions are given. Suppose this current carrying conductor and this is the point. This is the point P and this is length L. Okay. Then how you can find the magnetic field? So our formula B is equal to mu 0 I upon 4 pi y sine alpha plus sine beta. So this is your alpha, but beta is equal to 0. What is sine alpha? Okay, mu 0 I upon 4 pi y. This is the y. And what is sine alpha now? The sine alpha is opposite upon hypotenuse. So root of L square plus y square. So in this way you can find the magnetic field with the geometry. Suppose point is here, somewhere here. So in that case, suppose this angle is given alpha. and this angle is B1 beta. This is the alpha and this is the beta. So in that case, P is shifted right side. If beta, this is alpha and this is the beta, is okay. The alpha is both are positive. But now beta is left side. So my formula becomes mu 0 I upon 4 pi y sin alpha minus sin beta. Remember, one side alpha, other side beta, both are positive. But both angles are one side. Then sin alpha of course positive, but beta now becomes minus, negative બની જશે. કારણ કે આલ્ફા અને બીટા બંને કઈ બાજુ છે? લેફ્ટ સાઈડ છે. અહીંયા આલ્ફા અને બીટા બંને બાજુ છે. આલ્ફા અહીંયા છે, બીટા બાજુ, તો બી પોઝિટિવ. તો આલ્ફા તો પોઝિટિવ લેવાનું, પણ બીટા જો રાઈટ સાઈડ હોય તો પોઝિટિવ હોય. તો આ તો લેફ્ટ સાઈડ છે, એટલે મારે શું લેવું પડશે? નેગેટિવ. Using trigonometry also we can show it is negative. Same thing, if point is somewhere here, then I have to take this angle negative and this positive. If point is this side, તો બીટા પોઝિટિવ લેવાનું અને આલ્ફા નેગેટિવ લેવાનું છે. તો આ બધી ફોર્મ્યુલા તમારે લર્ન કરવી પડશે. then and then you will be able to solve the problems. તો સરસ રીતે નોટ કરવાની તૈયાર તમારે પ્રિપેર કરજો. નોટ ફોર્મ્યુલા અલગથી લખતા જવાની છે. ન સમજાય તો તમારે પૂછી લેવાનું છે. તો આજે આપણે શું કર્યું? એમ્પિયર સર્કિટલ લો કર્યો. શોર્ટમાં જોઈ લઈએ. એમ્પિયર સર્કિટલ લો, સોરી, integration B dot dl is equal to mu 0 into sigma I. And we derive one formula for illustration 4.8. ચેનલને તમારે સબસ્ક્રાઇબ કરવાની છે જેથી કે નોટિફિકેશન મળતું રહે. થેન્ક યુ.